So we're going to make a confidence interval. The confidence interval looks like d bar plus or minus t alpha over 2 s over root n, like that. I'll put d here for s for the differences. And the degrees of freedom, we said it was 13. We'll take, we'll do a 95% confidence. So that means we're looking for t 0.025. So the story is this: the 95% is the middle piece here. The t we're looking for, it sits there, and there's 2.5% on each end. So we look for a tail probability of 0.025, half of the 5% that's left over after you subtract. So alpha is 1 minus 0.95 for the 95%. That's 0.05. And alpha over 2 is 0.025. And then I'm going to go here to the tables, and we're 13. So here's 0.25 and 13. 2.16 is the critical value for t in this situation. So 2.16. All right. So that is 2.16. I'm looking for more numbers. We have them over here. S was 0.406. N was 14. And D bar was 0.3628. So there is the confidence interval. And we'll just, we'll make it. So here we go. 0.3628 plus 2.16 times 0.406 divided by the square root of 14. Let me double check that. That was right, wasn't it? 0.25, 2.16. Yep, okay. So the top end of the interval is 0.597, say. And then I'll go second enter to retype that. Second enter. And I'll scroll back here and make that plus a minus sign. And hit enter again. So 0.128, 0.128. So that says we're reasonably sure the treatment effect of oat bran is somewhere in this range. That 0.128 probably has no consequence. This might also have no consequence, but that certainly seems tiny to me. The reason is the sample size is 14. We can't really narrow it down to a long-term mean that's very close to some particular number. So if these kinds of numbers are of interest to the medical profession, they would do an experiment with a couple hundred people and see what the true treatment impact is, where they have more control over that random variation that's happening from person to person. On the other hand, you might go, if there's that much random variation person to person, then maybe it's not a very effective treatment for the population. It's only good for some people. How could you identify those people? Good question. And now we're going to let the calculator do all the work. Here we go, stat tests. Now I want a t interval. Okay, I'm in there. We're going to use data. We're using list 3. That's where the differences are. The frequency 1, that sometimes you have a frequency list there to tell me how many times I see different values, but they're all separate values. Confidence level 95, everything's good to go. And if I don't get that, I'll just get sad. There it is, 128 597. We emerge victorious from the calculator. Yay. We've done everything you can do today with match pairs examples, confidence intervals, and hypothesis testing by hand and by calculator. And I can stop recording now because I've finished my job. Yes, sir.